Hello, everyone. Welcome to Module 2, Lesson 3. We are going over graphing techniques and specifically transformations. And there are 4 different types of transformations that we are going to go over. Now, if you can understand this function notation here, this lesson is extremely easy. If you do not understand this notation, then this lesson may not make any sense to you whatsoever. Hopefully down here is going to help you be able to read our function notation a little bit easier. So the first transformation that we're going to go over are vertical shifts. So when I have some function and I add a number to the very end of it, that is going to make my graph shift up k units. So then opposite, when I have a function and then I subtract k at the very end, then that's going to shift down k units. Okay, so our vertical shifts are predictable. Plus means up, minus means down. So let's come down here and let's explore what that is actually meaning. So from last lesson, we went over key functions. I call them parent graphs, but I think here they call them key functions or key graphs. So from that, if you kind of pause the video, maybe take a moment to kind of think about what some of those key functions are. Okay, so hopefully you have kind of thought through. I'm going to list these in no particular order, not even the order we went over them in, I don't think, but the functions that I want to kind of put here are x squared, x cubed, the square root of x, the cubic root of x, and the absolute value of x. So these are our most basic functions. This one has a vertex at the origin. This one changes directions at the origin. This one starts at the origin, changes directions at the origin, and it has that V right there at the origin. So all of these here are just the basic functions. So up here, I have f of x plus k and f of x minus k, which is exactly what's right here. When I am talking about f of x plus k or f of x minus k, I am taking this function here and I am adding something over here to the very end or subtracting. So this could be x squared plus 1. This is x cubed minus 2. This is the square root of x plus 3. And I like to kind of make this little thing here so I know where that square root ends. Here we have the cubic root of x minus 4, and then the absolute value of x plus 5. So I have whatever this function is, right? And these aren't the only functions that we can have. Whatever my basic function is, I am adding something to the very end. And what this does is it moves it in a direction. So this goes up 1, down 2, up 3, down 4, up 5. Okay. So we're going to go back and forth between these two charts. So the next one is going to be our horizontal shift. Our horizontal shift happens when I am adding, subtracting something inside of my function. Okay. Now, unlike my vertical shift, that is predictable, plus k is up, minus k is down. My horizontal shifts predict opposite of what we think. So when I have x plus h, we think plus means going, if you like think of a number line, right? You think of plus h as going over here to the right towards the positive numbers. But this is actually going to shift to the left h units. So then likewise, minus h, you think is going over here towards all the negative numbers, but this shifts to the right, h units. Okay, so let's flip back here. Now I am taking whatever my function is and I'm adding or subtracting something inside. So my parabola, my x squared, is now x plus 1 quantity squared, right? This grouping here means it's happening inside the function. We have x minus 2 cubed. We have the square root of x plus 3. We have the cubic root of x minus 4. We have the absolute value of x plus 5. So now that these are all happening inside of the function, right? Inside the grouping, under the radical, inside the bars. Now this is horizontal. Now it's going to the left and to the right. So this is left 1, right 2, left 3, right 4, and left 5. If you do not understand the difference here between this notation and what is happening in these boxes, how they are different, how these are different, and how these are alike, then you either need to pause this video and rewind it and rewatch it, or you need to come talk to me. If you do not understand these, the notation, or how these are different, how these are the same, then this lesson is difficult and it's not going to make any sense, right? But if you understand it, this is so easy of a lesson. Okay, the next thing we're going to go over is vertical stretches and compresses. When I have my function and I multiply something in front, and whatever this something is, we're calling it a. If a is greater than 1, then we have a stretch. So this one here is stretched vertically. By a factor of a. When I have the exact same thing, my function, and I'm still multiplying it by a, but now a is between 1 or 0 and 1. So that's your 1/2, your 1/4, your 0.1, your 0.15, your 0.157. Okay, if a is not bigger than 1, but it is between 0 and 1, then we have a compression. So these have been compressed vertically by a factor of a. And I'm going to make a short video that's after this one that's not actually part of your notes, but will show you what vertical stretches and compresses are. A lot of times we'll say that a stretch gets skinnier, but that's not the case. That's not what we call it. It is a stretch. A lot of times when we see a compression, we say that it is getting fatter, but again, that's not actually true. And so if you watch the video I make after this, I will show you why we don't call it skinnier and fatter and why it is actually a stretch and a compression. And we don't have anything here to fill in by that. So it's just whenever you have something in front. And then the last thing we're going to go over are reflections. We again need to know the difference between this notation, right? And this notation is super similar to this. Is the negative outside of the function or is it inside the function? When that negative is in front of the function, These have been reflected across the x-axis. And when that negative is inside, then it has been reflected across the y-axis. Okay. Again, do you understand this function notation? When I have it reflected across the x-axis and that negative is in front of the function, you're literally just putting it in front of this. So this is negative x squared. This is negative x cubed. The negative square root of x. The negative cubic root of x. The negative absolute value of x. But when it has been reflected across the y-axis, it is now inside of my function. So this is in parentheses x squared. In parentheses, negative x cubed, right? In parentheses, negative x squared. In parentheses, negative x cubed. The square root of negative x, the cubic root of negative x, and the absolute value of negative x. Outside the function, inside the function. If you understand this chart and how it is different, this is an easy lesson. If you do not understand this chart, if you don't understand how these two columns are different, and if you don't understand how these two columns are different, you need to rewind the video or come talk to me.